Hi everyone, and welcome to the third lecture. So let's talk about RC circuits. That is when we have both the resistor and the capacitor in the circuit. When we are talking about both resistor and capacitor in the system, we are taking a look at a circuit that most probably looks something like this. Now, because we have two types of devices that are providing resistance in the circuit, now we need to generalize our concept of the resistance. To that end, we define a quantity that has a special name, and its name is impedance. So this impedance we show with the capital letter Z, and I can define it to be Z equals to square root of R squared plus X sub C squared. So remember that R here is a resistor and XC is the capacitive reactance. So it seems that this impedance is generalizing and including both resistor and the capacitor in it. So again, because it is a general form of resistance, its unit is ohms. So now with defining of this quantity here, everything else is going to be the same. So we can talk about Ohm's law, that was V equals to IR, but now this becomes V equals to IZ. So no matter what components we have in the system, this Z is always valid. So we'll take a look at different examples as we move forward. Now if V is the RMS, then I is the RMS here. If V is a maximum here, then I is a maximum. But Z can include all the components in the circuit. Now let's take a look at exercise 24-7. It says a given RC circuit has R 225 ohms, C equals to 32.8 microfarad, and F equals to 60 hertz. What is the impedance of this? So I'm writing the known of the problems and I'm looking for Z. It's useful here to first break XC to its equation, which was 1 over omega C. So I can write the impedance to be square root of R squared plus 1 over omega C squared. And then notice that usually in the problems we are given the frequency, not the angular frequency. So we need to define omega to be 2 pi f. And it seems that I have forgotten to put the capacitance here. Now this equation is correct. Now let's plug in the numbers. Okay, so I'm plugging in the numbers, and so just don't forget to convert the capacitance from microfarad to farad, which is this I unit for it, and then if I can calculate them correctly, then the impedance will be 239 ohms. So again, as I told you in the previous page, so if I want to just write down the equation to find I max, I can use the general form of the Ohm's law, which gives me V max equals to I max Z, or short form, to be more elaborate, I max times square root of R squared plus X sub C squared. So this yields to I max to be V max divided by the impedance. And again, notice that this is only for the circuits that we have R and C. Now let's see what happens if I only have, for example, R. So if I don't have C. So if I don't have C, of course, then I won't have this component, and then I max will be V max divided by R. So this makes sense, right? So this is the same equation that we had for the case that we only had resistor. Now let's see what happens if I don't have the resistor and I only have the capacitor. Again, using from the most general form, so I know that Imax is Vmax divided by impedance, and impedance is the square root of R squared plus XC squared. So if I do not have R here and I only have the capacitor, then of course R here is going to be 0, and then Imax is going to be Vmax divided by VXC. Okay, so this is exactly the same thing that we were using before. So what I'm trying to tell you here is that you can simply treat Z as the most general resistance form. Okay, let's go back to page 855 and take a look at the phasor diagram for the RC circuit. So if you remember, the Imax and the voltage across the resistor, which was the Imax R, should point in the same direction, because for the resistor, voltage and current do not have any phase difference. They are in the same phase. Recalling you that this angle here is theta, which equals to omega t, and this is the angular frequency of my current. And then, of course, you remember that when we had the capacitor only, then the voltage across the capacitor was lagging the current by 90 degrees. So this is the voltage across the capacitor, which we showed by Imax XC. Alright, so these two guys have the 90 degree of difference. Okay, now if I want to just have the summation of the voltage across the capacitor and the voltage across the resistor, so I need to sum them with the vector summation. So I can sum them with the vector summation. So this is going to be the maximum of your voltage, or total of your voltage, which is Imax times the impedance. So we're talking about the vector summation here, so it makes sense if I write Vmax is the vector summation of Vmax across the resistor squared plus Vmax across the capacitor squared. Okay, let me go ahead and just add this max here, so we know that these quantities here are the maximum that we are talking about. Maximum across R, and here I have maximum across the capacitor. Okay, so this is the same thing that we were talking about, that Vmax equals to Imax R squared plus Imax XC squared. Okay, so I can bring out the Imax from the equation. So it's become Imax square root of R squared plus XC squared, and this part was the impedance. So this is just the derivation for this equation, and you do not need to memorize it at all. Just wanted to show you how it is derived. Okay, so with this explanation, I let you study example 24.8 at home, but let's take a look at example 24.9. It says an AC generator with an RMS voltage of 120 volts and a frequency of 60 Hz, which is the normal frequency in the United States, is connected in series with a 340 microfarad capacitor and a resistor of resistance R. what value must R have if the RMS current in this circuit is to be 2.5 amps? Okay, as usual, we just write down the known of the problem and we are looking to find R. I am going to start with the general equation impedance equal to square root of resistance squared plus the reactive capacitive reactance squared. If I rearrange this equation, then I can find R to be square root of Z squared minus X sub C squared. In order to find R, I need to find the impedance and the reactance separately. From Ohm's law, I know that impedance can be written down in the form of V divided by I, and because I'm given the RMS values, I just plug in the numbers in this equation. So that will be 120 volts divided by 2.5 amps, which gives me 48, and don't forget that the unit is ohms. Now let's try to find the capacitive reactance X sub C. So this is very similar to what we had before. Now I'm going to write 1 over omega C and then break omega to be 2 pi f and then plug in the numbers. And again, we do not forget to convert the capacitance to farad. So with this, XC equals to 7.8 with the unit of ohm. Okay, now I can find resistance from this equation here, plug in the numbers, and then you get 47 ohms. This is your final answer. In previous sections, when we only had resistor or when we only had capacitor, it was easy to find power, right? So the average power. Now, the thing is, like, we have seen how to calculate the current in an RC circuit and how to find the voltages across each element. Now, if we want to connect or find the relationship between the power consumed by a circuit and then the impedance, it's going to be a bit complicated. So we need to find the phase relationship between the total voltage in the circuit and the current first. Okay, so we should define a new angle that is called the phase angle, and it's defined by R divided by Z, the resistance divided by the impedance. Now, if I want to show you what this phi is, let's go back to this diagram here. So phi is the angle between the total, this guy here is the total voltage, but in its maximum, and phi is the angle that the total voltage has with the I max. So phi is this angle here. Okay, now with this definition I can find the power, the average of power that is being the average power that is consumed by a circuit to be IV cosine phi. So this part, the IV, was what we had before in like previous chapters. Now what is new here is that because we are looking for the average of power, then this I should be root mean square, the V should be RMS, and now we have this new factor that is called phase angle. Or rather, the cosine phi is called power factor, and then the phi itself is called phase angle. Okay, let's just solve one last example on this topic and finish this section. Example 2411. It says that an RC circuit has an AC generator with an RMS voltage of 240 volts. The RMS voltage in the circuit lags behind the RMS current by 56 degrees, and the RMS current is 2.5 amps. So again, as usual, I'm writing down the known of the problem. Because the problem says that the RMS voltage lags behind the RMS current by 56 degrees, I know that it's talking about the phase angle here. Now in part A, we want to find the value of resistance. What is the resistance here? Okay, the equation that I start with is the definition for cosine phi, which was R divided by Z. So from here I can find R to be cosine phi times Z. So because I have the phi, I can find the impedance and then I can find the resistance. Okay, now the question is how to find Z. Well, in that case it's very easy. We have two values here which helps us find Z. According to Ohm's law, V RMS equals to I RMS times Z. Okay, so from here Z will be V RMS divided by I RMS. So it's going to be 240 volts divided by 2.5 amps, and then Z is going to be 96 ohms. Next, let's just plug in the Z into the this equation here. So R is going to be cosine 56 degree times 96 ohms. If you calculate it, this is going to be 54 ohms for R. Okay, part B is asking me to find the average power consumed by the circuit. So again, I'm using for the average power. We had a simple equation for this. P average is I RMS V RMS cosine phi. So what's easier than this? Just to plug in the number. P equals to 2.5 amps times 240 volts and cosine 56 degree. So this is going to give me the result 340, and what's the unit for power? Watts. Okay, now I hope that you enjoyed the lecture for this section. As always, I'm going to ask you to please send me an email if you have absolutely any question. If you are stuck in any part, if you think it's very difficult for you to understand. Now, it will be helpful if you just study your book and take a look at all the diagrams and the pictures, because no matter how much here I try to just like record a video for you, it's always more helpful if you study the textbook itself, especially the conceptual question that gives you a better idea of how this is applied in real life, and it helps you visualize the problem. Please be communicative and please stay safe.